In this lecture, we're going to learn about dangling pointers and reference in the context of class objects. A pointer or reference is said to be dangling if it is pointing or referencing something that is not valid anymore. And if you try to use a dangling pointer or reference, you will basically be manipulating memory that doesn't belong to you anymore, and your program might crash or have some other really bad problem. You don't want to be using dangling pointers or references in your programs. Let's try and really understand what we mean by dangling pointer or reference, and we're going to use a pointer in this case. Suppose we have a pointer that is pointing to an object in memory, and then after we use the object, we are done with it, we're going to delete the object. But the pointer is still going to be there. It's going to be pointing to memory that is no longer ours because we have deleted our object from that memory location. And the pointer is going to be there basically pointing to a shell object which is no longer there. If you try to use this pointer in your program, hopefully you can see that bad things might happen. You will be trying to manipulate, for example, read and writing into memory that is no longer yours. And you might be, for example, manipulating memory that belongs to the operating system or memory that belongs to other programs. This is really bad. And in most cases, the operating system is going to see this and stop your program completely, and you are going to crash. So a good practice is that after you delete your objects from memory, you're going to set your pointer to point to null pointer. And this is going to make this a little safer because people can check and see if your pointer is not a null pointer. We can basically do null pointer safety and make our code a little easier. But we can't really do this with references. We can't check if a reference is null because the reference can never be null. So if you try to use a dangling reference, you're going to have a disaster, and we don't really have a way to check and see if a reference is referencing something valid or not. If you have a reference, it is assumed that it is a valid reference. And this is an even more compelling reasons to make sure you don't have dangling references in your programs. So here we have a simple example which is going to show how you could come up with a dangling reference. We have a simple function which is a member of our class dog here. The name of the function is compile dog.info, and it's going to return a const std string reference. Okay, so this is a ceph function. It's not going to be modifying the object. It's just going to be reading data from the object. And look at what we do in the body here. We are setting up a string local object, and we are basically putting this together. We have the dog name n, we have the dog breed n, and we have the dog age in here. And we're going to store all this information in this string object. But look at what we do here. We are going to return this. And the moment this function returns, the local object, which is this string here, which is called info, is going to be wiped out from memory because it is a local stack object. And the reference we return here might stay there long after this function is done executing. So if we try to use this reference somewhere later after we call this function, we will be setting ourselves up for a disaster because this is a dangling reference. It is no longer referencing valid data because what it was referencing is long dead. It was wiped out after the function here finished executing, and this is a bad reference. You shouldn't be using it. If you use it, you're going to be having problems. This is what I want you to see here. But we can also have the same problems with pointers. Suppose we have a function here which is going to return an int pointer, and it is a const member function. It's not going to be modifying our object in any way. And this is a member class because we see that it is part of the dog class here. So look at what we do in the body. We are setting up a local variable and we are returning it. So we are returning the address of this variable, and when this function finishes executing, this pointer might be alive, and if we try to use it, we're going to basically be dereferencing something that is already dead. It's no longer going to be there, and something else might be living at this memory address already. Hopefully you can see that if we try to use this pointer somewhere after this function is done, we're going to be setting ourselves up for a disaster because we will be using memory that doesn't belong to us anymore. So this is really what I want you to see, that dangling pointers and dangling references are really bad, and you should watch out for these things to come up in your program, whether you are using classes or not. But in this case, I want you to see that these things might pop up even if you are using your classes and member functions like we just saw here. Now that you know this problem, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is dangling pointers and references. We are going to reuse the code from the last lecture because we're going to be using a dog class as a use case here. So let's copy all these things and put them in here, and make sure you have the VS Code folder here, because that's going to contain the settings that we want to use for our project here. So we're going to open this little guy in Visual Studio Code by dragging and dropping here. This is going to open our folder. We're going to have our main function, and what we really are interested in is modifying our class a little bit. Let's take out the const here and go in our class. We're going to go in our header file, dog.h, and we're going to set up a function which is going to compile dog information. So we can come here because that's going to be a utility function. So we're going to say std string because we want to return a copy. So we're going to say const std string reference. Let's say std string, if I can type this, reference, because we want to return a reference and show you that a dangling reference can also be bad. We're going to call this function compile dog info. It's basically going to put all the information together and return that to us. And we're going to set up a local string object. We're going to say std string information, or say dog info. I think this is more descriptive. And we're going to put all this information in here. So we're going to say dog name, or we could say dog name. So we're going to say dog name, and we're going to put the member variable mName here. Now we're not going to use the stream output operator. We're going to use the append operator. We're going to add this here. We're going to say mName, and we're going to go to the second line here and say plus. We want to append, and we're going to say dog breed, and we're going to say mbreed. We're going to add, or append I should say, and we're going to go to the third line here and say dog age. And we're going to take the number here and turn this into a string. The way we're going to do that, we're going to say add std to string, and we're going to pass mh here. This is going to work. And if we do this, we're going to have our string with the information about our dog object. This is an innocent function. It's going to be a const member function. I forgot to say that, because it's really not modifying our object. We are just reading from the object and creating a copy of a string, which is going to contain the same information in the form of a string here. Now that we have this string, we might want to return it from the function dog info. Let's say that. You're going to see that Visual Studio Code is not going to have any problem with this return statement here. Let's wait and see the squiggly line go away. You see that this is cool, this is working, and you might think that this is a cool and safe function. But if we go in main and for example set up a simple reference, we're going to say std string reference and say strref. I think this is going to do, and we say dog1 compile dog info. I think we have this function. Why isn't this working? So let's just put this in here. Let's grab the name of the function because I don't want to make a typo here. We're going to grab that, and we're going to copy and put in the main function, and we're going to call this function and assign its return value to another reference object here. So we're going to build with GCC and see if this actually works. And you see that we have 3 columns here. So let's fix this. That's the error we see here. We're going to build again, and you see that we are trying to call compile dog info not on the object. Let's do that. I am probably tired, but let's do this. And now we should have no problem calling this function from our dog object. Let's build again and make sure this is working correctly. And for example, set up a const reference to a string. We're going to do that. We're going to say const std string reference, and we're going to say strref here. And we're going to call the function and assign the return value of that function to this reference here. So we're going to put the assignment operator and we're going to say dog1 and we're going to say compile dog info. If we do this, let's see what happens if we try to build this program. You're going to see that build finished with warnings, and we have a warning because we are returning a reference to a local variable. So the compiler is really trying to save us from the error we are trying to do here. If you look here, we're going to see that reference to local variable dog info returned. So this is a warning we have, and we should really fix this problem, but we are stubborn. We're not going to fix this. We want to see what could happen if we really use this. This is really bad because now we have a reference to something that is already dead, because at this point, when we have assigned to this reference here, the compile dog info function has run and finished, and the return value has been assigned to strref. If you go down here and print strref, you could really get anything, because we are trying to read from memory that is no longer ours. So let's try and print the information, and we're going to say strref. We're going to print this and see what we get. We might get correct information, but we might also get something wrong, or in extreme cases, our program might even crash. We don't really know what is going to happen here because we have a dangling reference here. It's no longer a reference referencing something valid, and you should really watch out for this. Let's build again. You're going to see that the build is going to finish with warnings. So we have our executable. We can bring up a terminal and clear and try to run Rooster. And you're going to see that we're going to crash. We're trying to print information, but the operating system is going to notice that this program is really crazy. It is trying to access something that doesn't belong to it, and it is going to kill it. The program is going to be killed before it reaches the end of the main function here. Let's say done here so that you can really see this. Our program is going to crash and it's not going to say done. It's basically going to be killed at this line here when we try to use a reference which is dangling. Let's build again. Okay, the build is going to be finished with warnings. We can clear and run Rooster. And the program is going to try, but the operating system is going to see that this is a bad program. It is reading stuff that don't belong to it, and it is going to kill it. And we're going to die before we print the last line here. This is really bad. We might have the same problem even if we use references. So let's go down and set up another function which is going to return an int pointer, or unsigned int pointer to be exact. And let's say this function is going to give us how many times a dog can jump per minute. Let's say jumps per minute. It is going to be a const member function. So let's say this. And let's say it is a const pointer because we don't really want to modify the object. This is a const member function. And what we're going to do is set up a local variable. We're going to say unsigned int, and we're going to initialize this with 5, for example. You can put in whatever you want. And then we're going to return an address of this variable. Again, this is going to be a dangling pointer because we are returning a pointer to a local variable. I actually think we can remove this const here because we're not modifying the object here. We are just returning the address of a local variable. This is going to work. But notice that what we're going to have is a pointer to a variable that is already dead when the function here finishes executing. And we can go back in the main function and actually prove this. So we're going to comment out our reference code here, and we're going to set up an int pointer. We should say unsigned int pointer. We are going to say int ptr, and we're going to assign the return value of the call to our function. We are going to say dog1, and we're going to say jumps per minute. And if you do this and try to compile the code, let's see what we get. We're going to see build finished with warnings, and we basically have the same warning we had with references, but now we are returning the address of a local variable. And this is really bad. If you try to print this, you might get a crash. So let's do that. We're going to say jumps per minute, and we're going to dereference our pointer and say int pointer and do stdendl here. If we try to run this program through GCC, let's do that. You're going to see that the build is going to be finished, but with warnings. So our executable is going to be generated, but it will be a problematic one. If we try to run Rooster, we're going to see that our program is going to crash because we are basically trying to use memory that is no longer ours. And the operating system is going to say, this program is crazy, I am going to kill it. and your program is going to crash before it hits the end of the main function here. This is the message I wanted to give you in this lecture. Dangling pointers, dangling references, they are bad things. So you should really try and avoid using dangling pointers and dangling references in your program, because you are going to be crashing a lot if you do that. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to try and really zoom in and look at everything we have seen about const so far in this chapter. Go ahead and finish up here and meet me there.